Hello students, welcome to IMS Academy GATE Foundation course on network theory subject. So earlier we are having total 6 sessions we have conducted regarding network theory subject in the foundation course. There we have discussed regarding the network elements like active elements, passive elements, all the classification we have discussed, and regarding the passive elements and active elements we have discussed in detail, right? So today is the first session regarding the basic laws. Okay, regarding network theory subject, earlier we are having 6 sessions, continuation topic, that is basic laws, but regarding basic laws this is the first session. Okay, so this is the topic common for all the 3 branches, EC, electrical, instrumentation. So all of you kindly share this video link with all of your friends so that they also will attend this session live, and they also will get benefited from this particular session, right? So all of you quickly like and share this video link with all of your friends, and whoever visiting our YouTube channel very first time, whoever watching this particular session very first time, right, at our IMS Academy YouTube channel, so kindly click on the subscribe button and then click on the bell icon so that you will be getting instant notifications whenever we are conducting the upcoming live sessions, right? So before going to start today's session, I am going to give 2 important updates. So the first update is regarding our Telegram channel. Okay, IMS Academy Telegram channel. Regarding this particular link, it is already provided in the description of this particular video. Whoever not yet joined in our Telegram channel, so kindly join our Telegram channel. It is free for everyone, right? So whoever joining, okay, what are the benefits that you are going to get if you are joining our Telegram channel? Say for example, currently one live session is happening regarding network theory subject at our IMS Academy YouTube channel, right? Similarly, whenever the upcoming live sessions are happening at our YouTube channel, so all the updates you will be getting in this particular Telegram channel. That is the first thing. And whatever faculties are writing on the digital board during the class live session, that particular notes we will be sharing in the PDF form. That particular PDF we will be sharing in this particular Telegram channel, and you will be getting all the important updates whenever we are conducting any seminar or webinar. And in addition to that, you will be getting all the important updates regarding government job notifications as well. And one more interesting thing, in this Telegram channel on daily basis our faculties will post one quiz question so that all of you can actively participate, and whatever the answer you feel correct for the given question, accordingly you can choose the option. Okay, the very next day our faculty will provide the solution. You can go through that particular solution. In that way you can get update, okay, your knowledge. So that means this is one of the unique feature that you are getting on daily basis. You are getting one opportunity to learn something new, right? So all these features you are getting for free of cost. Okay, anyone can join, right? So all of you kindly share this valuable information with all of your friends and juniors as well. Okay, and one more important update, here at our IMS Academy we are having live online program for the GATE aspirants whoever targeting for 25 or 26, right? So the program features are here, whoever enrolling for live online program, so all the students are having the access of 800 plus hours of live online classes, right? So during these live classes, here all our faculties will discuss each and every concept from the basic level to the application level, and in addition to the concept we will be discussing the variety of questions as well. Okay, the practice questions, GATE questions, right, in order to get good command over the concept, and not only that, in order to get good number of methods of solving for the given question, etc., you will be getting good command during the classes. Okay, but in addition to that, for every subject we are providing the theory book and then exercise book. Okay, so with respect to your branch, okay, all the exercise book together you are having 4,000 plus practice questions, right? So in these exercise books we are having 3 levels of questions in every chapter, like level 1, level 2 and level 3, right? So all that together, like with respect to EC branch or electrical, instrumentation, etc., right? So in the exercise book, so according to your GATE paper, you are having 4,000 practice questions, 4,000 plus practice questions. Whoever solving these exercise book questions, they are getting very good command over whatever the concepts you might have learned during the classes. Okay, and in addition to that, here at our IMS Academy we are providing one unique booklet, one special booklet, that is 34 plus years GATE question bank, right? So here in this GATE question bank, you can find all the recent 34 years gate papers, and along with that you can observe the solutions. Wherever required, our faculties have provided more than one solution as well, and for whichever typical questions, even our faculties have provided the video solutions, right? So you can observe the QR code present in the solution section. Just you have to open the QR scanner in your mobile and then scan that QR code, then the respective video solution will be played. So in this way, while you are solving or while you are attempting the questions from our GATE question bank booklet, you will be getting amazing experience, right? So, and in addition to that, here at our IMS GATE Academy, we are providing 130 plus online tests, which consists of various chapter tests, subject tests, all India mock tests as well, right? And then we are providing 12 My Plan sessions for all the enrolled students. So on an average, every student can book one My Plan session with the corresponding mentor, and they can get the proper guidance and study plan, okay, with the corresponding mentor, so that they can get very good success in the coming GATE exam, right? So all these benefits, whoever enrolling at our IMS GATE Academy for the live online program, they are able to get all these features, right? So whoever interested, you people can contact to any of these two numbers. Our counselors will discuss more about our live online program, right? And kindly share this valuable information for the students who were aspiring to write the GATE exam in 25-26, whoever want to get very good rank in the upcoming years. So kindly share this valuable information so that they will be getting benefited by enrolling at our IMS GATE Academy. Okay, right. I hope all of you are eagerly waiting for the session. So let us start. So in the last class, we have discussed regarding the dependent sources or control sources. We are having four types of sources, like voltage dependent voltage source or current dependent voltage source. Similarly, with respect to current sources, okay, voltage dependent current source and current dependent current source. All the four sources we have discussed with respect to the representation of that particular source, and then we have discussed regarding the sign convention, whether for independent source or dependent source, whether that particular source is delivering the power or whether the source is absorbing the power. Regarding that, we have discussed the sign convention, and we have discussed variety of questions as well in the last class. And at the end of the last session, I have given one homework question. So how many of you tried this question? This is the question I have given as a homework in the last class. Okay, whoever tried this question, you people can mention your answer in the chat, and whoever attending this session very first time, no issue. I will be giving some time for all of you. At least now you people can try, and you can mention whatever the among the four choices, whichever choice you feel correct, you can mention in the chart. This is a very interesting question which is asked in GATE EC 2009 for 2 marks. This is a dead easy question. Okay, once if you know the passive sign convention, whatever the sign convention we have discussed with respect to delivering power or observing power that we have discussed yesterday class, based on that concept, you can easily answer this question. In fact, you no need to use pen and paper for solving this question. That much dead easy question, and this, even though it is dead easy question, you see the weightage of this question, you are getting 2 marks. So like that in the GATE exam, okay, it's not that 2 mark question means it has to be tough. Okay, 1 mark means easy. It's nothing like that. Okay, sometimes 1 mark question can be tougher, sometimes 2 mark question can be easier. But you should be smart. Whichever questions you can easily solve without using pen and paper, especially those questions you should not miss during your GATE exam while you are attempting. Yeah, here you are having one circuit diagram, right? So here if you observe, you are having 2 current sources, okay, and you are having 2 voltage sources. All are sources only. Whatever the 4 elements they have connected in this circuit, all are sources only, okay. But here what they have mentioned, it is known that 60 volt source is absorbing the power. So here among these 4 sources, here you are having 60 volt source, here you are having, right? In this question they have mentioned that this 60 volt source is absorbing the power, right? So now all of you tell me, since they have mentioned that 60 volt source is absorbing the power, whether current has to flow in the in this direction or in the opposite direction. In which direction the current has to flow, because they have given the key important note point with respect to 60 volt source, that is absorbing power. Any guess? Either first case or second case, downwards or upward. Once if you able to identify the direction, after that this question is nothing. See, here they have mentioned 60 volt source is absorbing power. Whenever they have mentioned absorbing power, that means just consider passive element like resistor, right? So here current enters at where? Positive terminal. Whenever current enters at positive terminal, that indicates absorbing power. Okay, if current leaves from positive terminal, it is delivering the power, right? So that means current direction should be downward. Okay, if current enters at positive terminal, then that particular element is absorbing the power, right? Absorbing the power. Now you can, here the question is the value of the current source I. The value of the current source I can be among the following. One option will be correct, because this question is what? MCQ question. Obviously one option will be correct. Okay, you can do option by option verification. Okay, since we don't know which option is correct, okay, let us start from option A. Option A. So when you have considered option A, so I value I have considered 10 ampere. I value I have considered 10 ampere. Okay, then what is happening? This current is coming here to this particular node. In this branch, current 10 ampere is entering, right? In this branch 12 ampere current is leaving. 12 ampere current is leaving. Now if you observe carefully, to this particular node, total you are having 3 branches, right? Here in this branch 10 ampere is coming, whereas in this branch 12 ampere is leaving. If 12 ampere has to leave, now tell me, in this branch how much current has to come? Yes, if 2 ampere current enters to this particular node, then 10 plus 2 together 12 ampere is leaving. So that means whatever, according to this convention, here they have mentioned absorbing power, so that means current direction should be downward. Yes, it is satisfying. So that means option A is correct. Option A is correct. Now you can verify with respect to option B or option C or option D, the current direction will come upward. You can just, for easy understanding, I am considering suppose 15 ampere. If I value is 15, then out of 15 ampere, 12 ampere is flowing like this, the other 3 ampere should flow in this branch in the upward direction. Since the current flowing upward, it is delivering the power. Yes or no? Current leaves from positive terminal. That is the reason. Similarly, you can consider 13 ampere or 18 ampere. For all the 3 other than option A, for remaining all the 3 choices, this particular 60 volt source is delivering the power. Okay, if you carefully understand, okay, actually this question in the year 2009, they have framed the question as MCQ. Okay, obviously one among the 4 choices will be true, right? But nowadays, since you are having MSQ, even this question is having the scope to frame the question as MSQ. Okay, so for MSQ, either one option or more than one option can be correct, right? So here if you closely observe, here you can observe, since you are having from this particular node 12 ampere is leaving, right? So in this branch, if you are considering the current slightly greater than 12, say for example 12.1 I am considering, okay, 12.1 ampere is coming here, out of which 12 ampere is flowing like this. That means 0.1 ampere is going upward. So that means for here what I want to tell is, regarding the current source value I, if it is at least greater than 12 ampere, at least greater than 12 ampere, okay, then for all the possible values of I greater than 12 ampere, then this 60 volt source is delivering the power. Okay, whichever option, suppose the same question, instead of absorbing the power, if they want to frame the question as with respect to 60 volt source delivering the power, right? So the current source value I can be whichever options having the value regarding I greater than 12 ampere, all those options are correct. Similarly, if they are framing similar question, 60 volt source is absorbing the power, right? So that question regarding the current source value, if they are framing the question as MSQ, okay. So regarding I value up to less than 12 ampere, okay, for I value less than 12 ampere, for all those I values, this 60 volt source is absorbing the power. I hope all of you are getting the clarity. So actually this question is having the scope of MSQ with respect to delivering the power, with respect to absorbing power as well, okay. So in this way, whenever you are getting time, okay, after solving any gate question or exercise book question, any standard textbook question, okay, with respect to gate exam point of view, whoever sincerely preparing, right, after solving any question, if you are getting correct answer, okay, so it is fantastic, but generally most of the students will stop learning process at that stage, okay. But if you are having some interest and if you are having some extra time, you should not stop the moment you are getting correct answer, okay. Rather you just contemplate whether for the given circuit or as per the given context, whether this question is having any other scope. When you contemplate, then you may get ideas in order to solve the question in less time, like shortcut methods, or even whatever the other possible variety of questions based on the same circuit, same concept, okay. In this way, when you are able to get the ideas, the kind of learning whatever you are doing, that is like I can say you are on the right track, because ultimately for the network theory subject, it is such a subject, if you are able to visualize the given circuit or whatever the question is there, if you are able to visualize, if you are able to analytically thinking, then you can solve most of the questions without using pen and paper. That much magical questions will be there in the network theory subject, okay, right. So with this understanding, now let us proceed to today's our main topic, that is basic laws, okay. So here, so for the timing, I have framed this question as MSQ. All of you just give a try among the 4 choices which are correct. Identify the basic laws. Option A, Ohm's law. Option B, KCL. Option C, KVL. Yes, all the 3 choices, like option A, option B, option C, okay, all these are basic laws. In the introduction class also we have discussed the basic laws are Ohm's law, KCL and KVL, okay. So regarding Ohm's law, we already covered with respect to passive elements like resistor, inductor and capacitor. When we have studied in detail about the passive elements, there we have covered regarding Ohm's law, okay. So in this particular session and the one more session, continuation session, we will be focusing on KCL. In this particular session, we will discuss regarding KCL and we will solve few questions. And the next session, we will discuss the variety of interesting gate questions on KCL. And then upcoming 2 more sessions, we will focus on KVL. Okay. So in this way, whatever the 4 sessions we are having regarding basic laws, whoever attending these 4 sessions regarding basic laws, all the students will get good command how to apply KCL and KVL and how to solve the questions, given question in less time. You will be getting, in fact, variety of questions I am going to cover, so that all you people will get good command with the help of KCL and KVL, how easily we can solve the given network theory question. Okay. Right. So regarding KCL, I hope all of you know, okay, during your BTech in the first year, when you're having the subject network theory subject or network analysis, right, or basic electrical subject, right, you people might have studied regarding KCL, okay. So all of you can mention the definition or whatever you know regarding KCL in the chart, and whoever watching this session later, you people can write whatever you know regarding KCL in the comment section, okay. Yes, say for example, I am drawing like this. Yeah, say for example here I am having total 5 branches. Okay, all the 5 branches I have connected to a particular point, then it is forming a node. Okay, so total we are having 5 branches, and for the timing I have considered the current directions like this. So I1, I2, I3. Okay, in these 3 branches the currents are entering towards the node, whereas in other 2 branches I have considered that currents are leaving, right? So when you have connected multiple branches to a particular node, then what is happening? In few branches currents are entering, in few branches currents are leaving, right? So whatever, from whichever branches currents are entering towards that particular node, if you are adding all those currents, that will be equal to in whichever branches the currents are leaving if you are performing the addition, right? So that means here we can consider, so I1, I2, I3 currents are entering, so I1 plus I2 plus I3 is equal to sum of leaving currents, I4 plus I5. So that means we can consider KCL is nothing but sum of entering currents equal to sum of leaving currents. So this one I am labeling as equation number 1. So you can write like sum of entering currents equal to sum of leaving currents. Sum of entering currents equal to sum of leaving currents. Okay, or if you want you can write in another way also. Say for example, so from this particular node, okay, you can consider that in all the branches the currents are leaving. Okay, so from there you can just perform addition of all the leaving currents. Okay, sum of all the leaving currents we can make it equal to 0. Say for example, here I4 is leaving current I am considering like positive. Okay, similarly I5 current it is leaving, so leaving current I am considering positive. So here I4, I5 are leaving currents positive. Okay, whereas I1, I2, I3 actually entering. Okay, but here I am considering that sum of all the leaving currents equal 0. So that means if I3 current is flowing like this, that means in the opposite way minus I3 is flowing. Similarly, if I2 current is flowing like this, in the opposite direction minus I2 current is flowing. Similarly, I1 current is coming like this, minus I1 current is leaving, right? So in these 3 branches, minus I1, minus I2, minus I3 currents are leaving. So sum of all the leaving currents equal to 0, right? So sum of all the leaving currents equal 0. So leaving current I have considered positive. If current entering, that entering current is the negative. Or otherwise, in other opposite way, if you want to consider, if you are having I3, it will become minus I3 like that. Okay. So in this way, you can write this one more equation. So whatever the equation 1 here you are having, so whatever the LHS terms you are having, we have brought to the right hand side. From there you are getting like this. Or from this entire equation, if you are taking minus as common, suppose if you are taking minus as common, then from there we can write I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. So this one more equation. So here what I have considered, sum of all the entering currents equal 0. Sum of all the entering currents equal 0. So here I1, I2, I3 are entering currents I have considered positive, whereas I4, I5 are leaving. So if I want to consider like entering, that means opposite direction I have to consider. So then I4 will become minus I4, I5 will become minus I5. So in this way, so based on your convenience, okay, regarding KCL, you can follow like this: sum of entering currents equal to sum of leaving currents, or sum of leaving currents equal 0, or sum of entering currents equal 0. So you are getting 3 possible equations. See, whatever the other 2 you are getting based on the rearrangement of first equation, that's all. Otherwise, from the second equation we can write first, or from third equation you can write first. In this way, with the help of any one equation we can write any other equation based on your convenience. Okay. So based on your convenience, whichever equation you want to remember regarding KCL, you can follow accordingly. Okay. So I hope all of you got the clarity how to write the KCL at a particular node. when multiple branches or multiple elements are connected to a particular node. Okay. So with this understanding, now all of you try to choose among the given choices whichever are correct. This question is MSQ, either one option or more than one option can be correct. All of you give a try. This is a MSQ question, either one option or more than one option can be correct. Yeah, whatever the four choices here you are having, all the four choices regarding KCL I have given. So among the four choices, whichever statements are correct, that we have to choose. Choose the correct option or options. Choose the correct option or options regarding. Choose the correct option or options regarding KCL. So here the option A you are having like this. Sum of all entering currents. Sum of all entering currents to a node is equal to sum of all leaving currents. Yes, this is the first point we have discussed. In whichever branches currents are entering, we have to perform sum of those currents, and in whichever branches currents are leaving, we have to sum. So those two will balance. Yes, option A is correct. Similarly, option B you can observe sum of all the leaving currents from a node is equal to 0. Yes, we have discussed this one also. And option C, sum of all entering currents to a node is equal to 0. Yes, this is also correct. So whatever regarding KCL, we have discussed three possible equations. So regarding that, here we are having the sentences, right? So option A, option B, option C are correct. Now see the option D. This is the most interesting thing. KCL is independent of nature of elements that are connected to a node. Yes, here independent of nature of elements. Nature of elements means here types of elements like active elements, passive elements, linear, non-linear, etc. Right? Bilateral, unilateral. So here whatever the branches here I have connected, right? So in each branch you will be having some elements, right? Either single element or two elements, etc. So those elements can be of any type. So that means here KCL is independent of nature of elements. Okay, you can have DC source, you can have AC source, you can have resistor, you can have inductor, you can have capacitor, you can have voltage source, you can have current source. Okay, you can have dependent source as well or independent source, etc. Right? So that's why here KCL is independent of nature of elements. Okay, so all the four choices are correct. All the four choices are correct. Now all of you give a try. This is the MCQ question. MCQ question. KCL obeys which law? KCL obeys which law? Law of conservation of option A, charge, option B, energy, option C, both A and B, option D, none of the above. Which one is correct? Yeah, option A is correct. Option A is correct. See, for the time being, let us consider this equation 1. Okay, if you want, you can consider any other equation, no problem. But for the time being, I am considering equation 1. I1 plus I2 plus I3 equal to I4 plus I5. So equation 1 I am writing I1 plus I2 plus I3 is equal to I4 plus I5. So in one of the introduction classes regarding network theory subject, we have already covered regarding the relation between current and charge. I equal to dq by dt. The rate of flow of charge is nothing but current. Now we can substitute wherever current I you are having, in place of that you can use that expression, right? So here you are having suffixes, so accordingly you can put suffix here with respect to q. Okay, right. So from there you will be getting dq1 by dt plus dq2 by dt. Like that you can write in every term. Okay. Now on the left hand side you can take derivative term as common. Similarly on the right hand side you can take derivative term as common. D by dt you can take common. Okay, after that you can perform this addition operation like q1 plus q2 plus q3. Because differentiation operator is a linear operator, right? So if you are having like this, we can write like this, or when you are having like this, we can write like this, vice versa. Similarly here on the right hand side you are getting d by dt of q4 plus q5. Okay. Now you can perform integration on both sides, then integration derivative will get cancelled. From there you are getting the normal expression. So here you will be getting q1 plus q2 plus q3 is equal to q4 plus q5. Okay, so that means what is the observation point here? So earlier you can observe this particular example diagram. Here in these three branches, okay, so earlier we have discussed with respect to currents. Okay, now you can observe in these three branches in terms of charge, right? In these three branches, the net charge, whatever is coming to this particular node, the entire charge is getting distributed, okay, from that particular node in other branches. So that means at this particular node, there is no charge is getting accumulated. So that is the most important thing. Whatever the net amount of charge is entering or coming to that particular node, the entire charge is getting leaving from that particular node in all the other branches together, right? So that's why here we are telling that KCL obeys law of conservation of charge. Law of conservation of charge. Okay, you people might have studied regarding law of conservation of energy in the physics, right? So energy can neither be created nor be destroyed, right? It can be converted from one form to another form, etc., right? Similarly here, law of conservation of charge, according to that, whatever the net charge is coming to a particular node, the entire charge is getting distributed, okay, or leaving from that particular node in all the other branches, okay, right? So that means there is no charge accumulation is happening at that particular node. That is the most important thing. So KCL obeys law of conservation of charge, okay. Now with this understanding, now let us solve the gate question, which is very interesting. So all of you give a try. I will give some time for all of you. This is the question asked in GATE EC 1997 for 1 mark. All of you give a try. Yeah, whoever tried this question, okay, you people can mention whatever the option you are getting among the 4 choices, whichever option you are getting as correct, you can mention the chart. This is a very interesting question. See, regarding KCL, it is very simple law, or we can say it is easy law. Okay, anyone can apply for any given circuit. But the most interesting thing and important thing is, for any network or circuit which you are getting in the GATE exam, okay, how to apply that particular law, or from which particular node we have to apply, that is the most interesting thing. Okay, so for the time being, let us solve this question 2 methods, so that you are getting the complete idea. Okay, from any point we can start solving the given question, but ultimately you are getting the same answer. But with the help of whichever approach you are getting the answer quickly, obvious that is the shortcut method, or we can say that is the best method. Okay, whoever want to get very good rank in the coming GATE exam, right? So obviously the shortcut methods will play a vital role. Okay, but in order to get the shortcut method, first of all you should be conventionally strong. Once if your basics are strong, when you are contemplating on the basics and when you are contemplating on the given question, then from there you will be getting the idea. Okay, so by proceeding or by following whichever method, we can easily get the answer quickly. Obvious that is the best method. Okay, right. So now I will solve this question first of all in first method, and then we'll discuss in one more method. Okay, right. Say for example, here you are having the circuit like this. Okay, in this particular circuit, you are supposed to calculate the I4 value. Okay, right. So here you can observe. Say for example, I am starting from here. Okay, so here you are having a node. To this particular node, how many branches are connected? 1, 2, 3. 3 branches are connected, right? So here how these 2 elements are connected? Series, right? These 2 resistors are connected in series. Okay, so in series current will be same. So whatever the current 3 ampere is flowing like this, the same current is flowing in this branch like this. Yes or no? So 3 ampere is going like this. Okay, and in this particular branch 4 ampere current is leaving. 4 ampere current is leaving. Now just observe, to this particular node, total you are having 3 branches. Okay, out of which in 2 branches together how much current is flowing? 7 ampere. 3 plus 4, 7 ampere is leaving from this particular node. Now tell me, in this particular branch, whether current has to enter to this particular node or current has to leave from this particular node. All of you can answer. It is very simple. So in this way, whatever the KCL we are having, it's not that you have to write the equation. No, not at all required. Of course, even if you want, you can write the equation. From there you will be getting answer same. But most of the GATE questions you can easily solve by analyzing like this. Okay, just observe the branches that are connected to a particular node, in which whether the currents are leaving or currents are entering. So based on that observation, you can guess whether the current is entering or leaving towards that particular node in that particular branch, right? So here, as I mentioned earlier, 3 plus 4 together 7 ampere is leaving from this particular node. That means in this particular branch 7 ampere should come. 7 ampere should come. If 7 ampere is coming here, together 7 ampere is leaving, right? Now I hope all of you got the clarity. Now just observe, here in this particular branch the current 7 ampere is going like this. Yes or no? 7 ampere. Okay. Now you can observe, here you are having one more node, but to this particular node, here you are having 4 branches are connected. For this particular node, only 3 branches are connected, whereas for this particular node, in this given circuit, 4 branches are connected. Okay, now just carefully observe. In these 2 branches, 5 ampere and 3 ampere, these 2 currents are entering. Okay, in these 2 branches, currents are entering. So 5 plus 3, 8 ampere is entering towards this particular node. Now in this particular branch 7 ampere is leaving. Now with this understanding, tell me, in this particular resistor whether current has to leave or current has to enter. All of you just give it a try. I already given the hint point. See here 8 ampere is coming here, out of which 7 ampere is going like this, obviously here 1 ampere should leave. So that here net current 8 ampere is entering, resultant current 8 ampere is leaving. Yes or no? Right. Now, similarly you can observe here, okay. Yeah, you can consider this particular node. You can consider this particular node. Okay. So here you can observe in this branch 7 ampere current is coming, 7 ampere current is coming, and in this branch 1 ampere current is coming, and in this branch 4 ampere current is coming. So once again to this particular node 4 branches are connected, okay, out of which in 3 branches currents are entering, right. So just if you add 4 plus 1, 5, 5 plus 7, 12, okay, that means 12 ampere current is coming towards this particular node. The entire 12 ampere should leave. Yes or no? 7 plus 1, 8, 8 plus 4, 12. 12 ampere current is entering, so the entire 12 ampere should go like this. Okay, but actually the current direction is like this, but in this given circuit I4 current direction is opposite. That means I4 value is nothing but minus 12 ampere. I4 value is nothing but minus 12. Okay, I hope all of you are getting the clarity. In this direction 12 ampere, in the opposite direction minus 12. So that means option B is correct. Okay, option B is the correct answer. Okay. So I hope all of you got the clarity, okay, whatever we have discussed regarding method 1. Okay. Suppose in the given question, if they have given I4 direction like this, in that case you can consider 12 ampere. That is there in option A. Option A will be correct if provided if they have given current direction in the opposite manner. Okay. Now let us solve the same question with another method. With that method we can get the answer quickly. Okay. So if anyone want to give a try, so among these nodes, from which at what node if we apply KCL, because of that we can get the answer quickly. All of you just contemplate and mention your answer in the chart. After that I will proceed. Okay. So just for reference you can observe the previous circuit analysis. Now based on this analysis, now you can think of at what point if we apply KCL, or at what node if you apply KCL. Because of that directly you will be getting the answer. In fact, you no need to use pen and paper. That much dead easy question this is. But only thing, you should get the visualization, okay, and you should have good analytical skills. Once if you are having these two, most of the network theory questions we can easily solve in less time. In fact, some of the questions we can easily solve without using pen and paper. Whatever the calculation is required, that we can do by visualizing the circuit itself. All of you just give a try. See here, I have started KCL at this particular node, and then here, and then here, okay, and with the help of that I got finally. Now if you observe carefully, what we are supposed to calculate? We have to calculate I4 value. Okay, just observe at this particular node. Here in this branch 5 ampere current is leaving, right? In this branch 7 ampere current is leaving. Okay, just observe total 3 branches are connected to that particular node, out of which in 2 branches together 12 ampere is leaving. That's all. Just apply KCL here. That's all. Here 12 ampere is leaving. That means 12 ampere should come. If 12 ampere is coming to this node, then resultant 12 ampere is leaving in these 2 branches. That's all. Okay. But here the direction is like this. 12 ampere. But here in the given circuit, I4 direction is in the opposite. So because of that, I4 value will be negative. That's all. So in the previous method, we have started analyzing at 3 nodes. Okay, after that we got the final answer. But see the beauty of this question. If you are able to apply KCL at one particular node, okay, with the help of that, you are getting the answer directly. Okay, so in any method you can solve. From any particular node, you can start analyzing. After that, you are coming to get the final answer will remain same. But by following whichever method, if you are able to get the answer quickly, obviously that is the best method. Okay, so in this way, if you want to solve the gate questions based on KCL, based on the basic laws, okay, you should, after observing the given circuit, after reading the question, what you are supposed to calculate, just observe the given circuit carefully. From there, you will be getting the idea from which point or which node we have to start analyzing, so that we can get the answer quickly. Okay, so the first method, why I have discussed better in order to get good command over the KCL. Okay, because with the help of this method, see, while you are solving or while you are learning any subject, initially you have to follow the conventional approach, because the more you practice, the more you get the perfection. Okay, so initially, for that sake, whatever the KCL, earlier we have discussed one law, like 3 branches current is entering, 2 branches current is leaving, one equation only. But in order to get good command, so I have applied KCL at 3 points. Now you got the familiarity. Once if you got the familiarity, now actually for solving this question, this is the best method. The second method is the best. If you are able to apply KCL at this particular node, that itself is sufficient, because out of 3 branches, in 3 branches you know the current, that means one unknown, you can easily calculate, that's all. In this way, just observe how many unknowns or how many equations you required for solving the given circuit or question. Based on that, you can decide in whichever method you are getting less number of unknowns or less number of unknown equations or less number of equations to be solved. Based on that, you can decide. Obviously, the minimum number of unknowns or minimum number of equations to be solved, so definitely that method is the best method. Okay, right. So I hope all of you got the clarity. Earlier, with respect to resistors, inductors, capacitors, right, equivalent circuits, when we have talked about like series connection, parallel connection, etc., right, so there we have covered some of the basics. Like in series, whenever the elements are connected, right, so in series the current will be same, whereas in parallel voltage will be same. So here you can observe these 2 resistors are connected in series same current is flowing. Similarly, these 2 branches, okay, so in this branch 2 elements are there, one is current source, another one is resistor. These 2 are connected in series current will be same. Okay, so here actually one more interesting thing, whether you have noticed or not, so just I am giving one more important point here. In this given circuit, nowhere they mentioned regarding the resistor values. Okay, so whenever you are getting such kind of questions where resistor value not given or resistor value is like 1 ohm, etc., okay, so such kind of questions, if you carefully observe, okay, whatever the given information is there, with the help of that, when there is a possibility to solve the given question, that time in most of the questions, when you look at the previous gate questions, they never give the resistor value. Okay, even in some questions intentionally they can give the resistor value, but in fact that resistor value is not making any sense. In order to get the final answer, whatever you are getting, even whether you are having that resistor value or not, irrespective of that, you are getting the same answer. Okay, so in such cases, okay, in some questions or most of the questions, they never give that resistor value, or even if they are giving resistor value also. But when you practice good number of questions based on network theory subject, then you will be coming to know that whether we have to use that resistor value or not, etc. Okay, in this way, whatever the basic laws you have studied, with the help of that, just give a try. Suppose because of that, especially in some cases, wherever you are unable to solve the given question based on the given data, okay, then definitely you can choose option D, none of the above, or we cannot solve the given question, etc. Like that, if any option is there, that you can choose. But most of the questions, if you observe, when you get the time, you can observe the gate questions. Most of the questions, whatever they have framed, definitely based on the given data, you can solve the whatever the unknown they are asking. Okay, right. So I hope all of you got good command over the KCL. Okay, now this is one more gate question which is asked in GATE EC 2014 in set 1 for 1 mark. Okay, So in this particular circuit, you're having resistors like this, and here they have connected some branches and they have given the information. Okay, so all of you take the screenshot of this question and you people can try this question in your free time. So for the time being, I'm mentioning this question as homework. This is a homework question. Okay, so all of you give a try. Okay, for the given circuit, for the given data, okay, whichever option is satisfying. This question is MCQ, obviously one option will be correct. So among the 4 choices, whichever is correct, then accordingly you can mention your answer in the comment section of this particular video. Okay, so you are having time till tomorrow 2 o'clock. Okay, so till then, whoever solving this particular question, you people can mention your answer in the comment section. Okay, right. So for the timing, I am keeping this question as homework. I hope all of you can solve this question. See, don't hesitate whether your answer is correct or not. Okay, don't worry at all, because all of you are currently learning the subject, right? When you are learning the subject, suppose somehow that if you are getting wrong answer, no problem, because at least you are giving some try. And then suppose in the next class when I discuss this question in the beginning, right, from there, suppose if your answer is wrong, okay, then you can cross check from where you, at what step you have done the mistake or where you have done the mistake, etc. You are getting one opportunity to correct whatever the mistakes you have done earlier, right? So never hesitate. Whenever you are learning any subject, do as many new mistakes as possible, because with the help of each and every new mistake, you are getting new learning, right? But don't repeat the same mistake. If you are repeating the mistake repeatedly, that means you are not learning anything new. But if you are doing as many new mistakes as possible, that means you are learning a lot. Okay, so now you can decide whether whoever want to learn more, so I recommend that do as many mistakes as possible. Okay, but don't repeat the same mistake. Okay, right? If you are repeating same mistake, that means you are not learning anything new. Okay, right. So in this particular session, we have discussed one gate question which I have given as a homework in the last class. So regarding that, we have discussed based on the absorbing power or delivering. Okay, that one gate question we have covered, and then we have discussed regarding KCL and how to apply for the given circuit, that we have discussed, and one gate question we have discussed based on KCL, and then one more gate question I have given as a homework. That question I am going to cover in tomorrow's session, right? After that, we'll continue further some interesting gate questions based on KCL. We'll be discussing on tomorrow's session. Tomorrow we are having regarding basic class part 2. So in that session, I will be covering the variety of gate questions based on KCL. Okay, right. So once again, I am just giving whatever the 2 important updates I have given at the beginning. So once again, I'm just mentioning, whoever not yet joined our Telegram channel, so kindly join our Telegram channel. Regarding the link, it is already provided in the description of this particular video. And one more important update regarding the GATE Live online program for GATE 25-26, which we are offering at our IMS GATE Academy. Whoever interested, you people can contact to any of these 2 numbers. Our counselors will discuss in detail about the program details, everything. Okay, whoever aspiring to get very good rank in the upcoming years, you people can contact to any of these 2 numbers and try to get enrolled as soon as possible, so that you can get very good success in the coming GATE exams. Okay, right. So whoever not yet subscribed our YouTube channel, so kindly subscribe and then click on the bell icon and like and share this video link with all of your friends. We'll meet you all on tomorrow's session. Thank you everyone.